So the next question to ask is, what can combinations do for you? So combinations allow us to be able to figure out how many different combinations there are without order. So for example, in a standard 52 card deck, how many different possible 5-card poker hands are there? Now this isn't anything magical about poker. You can do this for all sorts of decks and all sorts of games. Canasta, bridge, whist, cribbage. In most card games, not all, but most, it doesn't matter what order the cards come in. What matters is that they're in your hand, right? Okay, so if that's the case, then what we really want is we want 52 choose 5, because the poker hands have no order to them. It doesn't really matter what comes first, what comes second. All right, and if that's the case, then I really want combination 52, 5. And I'll go to Excel and find it. Let me just write down what I'm doing. 52, 5, just so you can see. All right, equals combin 52, 5. That's it, right? 2598960. So 2,598,960 different possible. Different possible. Sorry about that. I pressed the wrong button. Different possible 5-card poker hands. Although technically it's any game that would have dealt you 5 hands. I mean, you could be playing gin with 5 cards, although gin technically is 7 cards, but you get my drift. Okay, so suppose Dale, Evan, Forrest, Gavin, and Hamish all have their names in a hat. And I picked those names because it goes D, E, F, G, H. Get it? All right. How many different ways can 2 equal prizes be awarded? No one can receive both. Okay, so you're going to give away 2 prizes, but they're equal to each other. So you want to say, okay, of the 5 people, what am I doing there? 5 people, I want to choose 2 of them. 1, 2, 3, yep, 5 people. I want to choose 2. Why choose? Why combination? Well, because they're equal prizes, so there's no order to it, right? So I'm going to go over here and just write, combin 5, 2, which is equal to combin 5, 2, 10. I actually knew that one off the top of my head, but I wanted to show you how to find it. All right, so 10 different ways. All right, now suppose instead of being equal prizes, suppose somebody's going to get a first prize and somebody's going to get a second prize. Well, now there's an order to it, right? Because there's a first prize and a second prize. So that's going to be a permutation. But I'm still choosing 2, I believe. Let me double check that. Yep. So first prize gets 500. Second prize only gets 100 or 200 or whatever it was. So that's permutation 5, 2. And let's go find that. Now notice, again, there's more options. When you have an order, that means that, let me just put it this way. So in this one, Dale and Evan, just for example, Dale gets first prize, right? So those 2 are the same thing, right? Evan, Dale. It doesn't matter. There's no order. But down here, that now all of a sudden, DE and ED are not the same, right? Because DE means Dale gets the first prize and ED means Evan gets the first prize. That's what makes the big difference. And that's why this is double the number of that. No, it's not always double. It just worked out this case because it's 2. So, but in general, combinations are always a smaller number than permutations. Permutations always give you more options because there's more ways for things to have an order to them. Okay, how many different ways can 2 of them be selected? 1 for first prize and oops, I already answered that. Yeah, it's the same question. So I don't know what I was doing there. So we'll just delete that repetition question. And then the difference between combinations and permutations is exactly what I was talking about here. In a combination, hold on, I'm going to pause so I can write this out for you. There, what I just wrote up above. Combinations have no order, so DE and ED are the same. Permutations, there is an order, so they're not the same. And that means there's more permutations than combinations.